Hey Pat, how you doing?
Hey, good morning, Mark. How are you? I'm doing great.
I believe we are live. Just waiting for a few things to kick in on my side here to make sure that we're up and running.
Yeah. Are we
Glorious.
live? Yes, we're
So
live.
thanks for joining me here. Welcome to Helium on Air, episode 4. I think we are at. We took a few weeks off to get some really exciting stuff out the door, and now we're back. So today we are going to talk about the Helium hardware suite, specifically things that you can prototype with. I've asked Pat Hickey to come along here and talk about a lot of these things because he worked quite heavily and continues to work quite heavily on these. Pat, why don't you introduce yourself briefly?
So, hi, I'm Pat. I've been a firmware engineer on this project and also worked on specifying hardware and bringing up all the early hardware. So I've been working with these boards now for a bit over 6 months, and I'm really excited now that they're in your hands and you'll get to do excellent things with them.
Yeah, we've have dev kits arriving in people's hands this entire last week, and we've been seeing some really good feedback early on. So a bit about your background. What did you do before Helium?
So for a while, I worked at a company called Galwa on basically research on cybersecurity problems in embedded systems. And some of the stuff I did there was building drones or other neat embedded systems. So been doing this for a while, and some of the embedded systems I've worked on have gotten into people's hands, but I think Helium is the best one yet.
Any declassified things from Galois worth sharing with the group?
Oh, we hacked a drone on 60 Minutes one time. That was fun.
Oh, yeah, that's right.
So I have a bacon number of 2 because I was on 60 Minutes. So that was fun.
Well, we can get that clip and link it in the comments for this video.
Yeah.
I definitely remember seeing that just after you joined Helium. Okay, so we are going to get into it here. We were having trouble with the slides beforehand. Let me see if I can share these things and actually make a decent stab at it. So are you seeing those? I believe we are.
Yeah, we're seeing this.
Cool. Okay, so we're going to talk about the hardware suite today. We're going to specifically focus on how it is that this stuff kind of makes it easy for people to prototype sensing applications. I will start with the shameless plugs now. At any point, you can go to store.helium.com and pick up all this hardware that we're about to talk about. We also just launched a glorious and beautiful new developer site called dev.helium.com. Typically, I have it written over my shoulder on the whiteboard, but I was having trouble with markers just before this episode. So store.helium.com, dev.helium.com, and then you can pop into chat.helium.com and talk to us at any time. So real briefly, to make sure that people have a full look at the Helium platform, and so we start on the left with some sort of sensing environment. We've been doing a lot of work kind of in and around manufacturing, so factories are very present in both Pat and my mind and kind of a lot of the company at this point. So we outfit some sort of machine or build a sensor from the ground up that does sensing on a machine. In this diagram here, we've got the Helium Atom Development Board, which is the primary target for prototyping, which is why it's included here. We've got the Element, which does bidirectional encrypted communication for sensors from the edge back to the cloud and vice versa. And there's a Helium Cloud, which does routing and storage and exposes all sorts of wonderful, easy-to-use APIs for developers. So the hardware we're going to focus on today, so this is the hardware overview, pretty much runs the gamut for what developers are going to use for prototyping. And we're not going to be able to dig into all this stuff in the 20 some odd minutes that we have left, but we can get a good overview. We'll start with the Element, which is probably the least important when it comes to prototyping because it just kind of sits there and does its job. And then we'll kind of move briefly through all the other pieces. So the point here that we're trying to get across is that all of these combined will bring to bear a very easy and very comfortable prototyping experience. Pat, I'm sure you can share some horror stories from what it was like building things, even a year or 2 years ago on tools that were a lot less kind of sophisticated than what we're bringing to the market here. So the general flow here is grab a sensor, plug it into the right piece of hardware from Helium. The dev board is going to underpin all of this. Write a quick touch of Helium script, which you can look at on dev.helium.com, and then deploy it. And what we mean by deploy is ship a script to a running sensor that runs on the dev board and get data back here. So Pat, why don't you start us off with a bit about, you want to talk about the access point a bit? You want me to take that?
Yeah. So the first question, because our access point photos don't have anything for scale, is, So what is this box? First off, it's like this size, smaller than my wireless router, which I think is pretty neat. And on the back, it just has an Ethernet jack and a power jack. And you can ignore that Professor Edition. This is an internal
limited edition model.
Limited edition. One of the cool things about it is you see the lights on right now, and it's not plugged in. It's got a battery backup. But we'll work on getting that kind of features into your hands in a couple of months. But what does the Element actually do? It's our bridge between the Helium wireless network and your internet connection via Ethernet, via Wi-Fi, or in situations where you might not have either of those, we can put a cell modem in it as well, and just get it out to the cloud. You don't have to provide anything besides just a power jack. You don't have to do any kind of setup. You plug it in and work. Security there, we're really keen on security because we know we've seen a lot of our customers in the industry have been burned on this in the past. One thing we're really proud of on the Element is it accepts no incoming connections of any kind. It will only make outgoing connections, and that's just exactly one connection to the Helium cloud.
One question I always get about the Element is, can I run programs on it directly? And the answer right now is no.
No, but we're hearing a lot of people asking for that, so we think it's important, and we're gonna hopefully have more news about that in the future. Okay. But please, if you're the kind of person who's thinking, oh, I really want to be running programs on that, let us know what kind of programs those are, what features you need.
Because when we do enable that sort of thing, it's going to be pretty powerful. Okay, so we'll move on from the Element because that's pretty straightforward. We've on this YouTube channel also we've got a few short overview videos of all these things we're going to talk about, say for the 4 to 20 milliamp, which will be available soon. So all right, so we've talked a bit about the Element. Now let's talk about the crown jewel here, the Atom development board. Take us through this briefly. Yeah.
So the Atom dev board, again, I'll just hold it up to the camera so you can see it. It's pretty small. It's short in stature. The biggest things that pop up are the battery connector and then the sensor bus connector there. And it's got these two whisker antennas. These are for our two wireless bands, our 900 megahertz and our 2.4 gigahertz. But this is everything you need to build a sensor on a single board. We tried to cram as much into a small package as we reasonably could, and I'm really proud of how much we got into it. It wasn't particularly easy, but this covers your wireless communication, the processor that does all of the scripting that's going to run your scripts. It's also got a lot of flash storage on there that we use not just for storing over-the-air firmware updates, but we also we back up all the sensor readings you've ever taken to that flash. And so that if there's some kind of power interruption or a network interruption, we can still get those up to the Helium cloud. So that's like one less thing you have to think about. You don't have to worry about failures of that sort.
What's sorry to interject. What's the quick back of the envelope math for temperature and pressure readings that show up once every 10 minutes? How long can we store those for?
I think when we did the math on that, it was something like a year if they're showing up every 10 minutes. So, certainly some applications you're going to be sending a lot more updates than one every 10 minutes. But, for a low bandwidth sensor like that, we have like a number of, I don't know the number, so I'm not going to say the wrong number, but it's
long though. Suffice it to say, you can store a lot of data.
We have tens of megabytes of storage for that, which, at a dozen bytes per sensor update, because we pack these things down really, really small.
Yeah. Okay.
So the processor, the environment there, we have a hardware security coprocessor on there. That's basically it's designed just for storing keys in a way that various sorts of software and hardware techs can't get at them. So that's state of the art as far as safety and security goes. It's got a USB interface. That's really like the thing we've spent a ton of time on in the development process is so many ways you're developing Internet of Things devices. You have to have these big external debuggers. You have to have a lot of tooling installed on your computer, a big IDE. We tried to make it as simple as possible. You plug in this USB cable, and you can instantly open the script interpreter onto the device. You can load new scripts. You can download the current script. You can do all kinds of interactive development, just like you're programming and the Lua REPL on your computer. The Lua REPL goes right to the board.
Yeah, the early feedback we've gotten on the I think we're calling it application semi-hosting has been super powerful. Just the speed with which one can develop and kind of iterate on these Helium scripts seems to be one of the huge advantages, which is great because that's what we plan.
Yeah. Yeah, I mean, I've been developing these kinds of like, talk to a sensor for a long time, and writing it in C, recompiling it, pushing it to the device, seeing if it crashed in some weird way because it's C. That's a really time-consuming process, and this shaves a ton of time off your iteration cycle.
Yeah, excellent. So before we jump to the next piece, talk a little bit about I2C, why we chose that as the protocol to support natively out of the box, and then the last thing to touch on, how do we do multiple I2C inputs in parallel?
Cool. Okay, so the way you're going to talk to sensors on this board is through the sensor bus connector. So we picked a nice big 0.1 inch pitch connector there, so that it would be really easy to solder by hand or to use these pre-made cables. We found all kinds of great pre-made cables where this takes the connector and it brings it out with different colors for each channel into these female headers. You can also like go and get wires that do that and plug them into your breadboard. So the prototyping aspect there is great. And what we found is for I2C is that so many sensors speak I2C natively now. And that's mostly because these sensors are found in smartphones and other embedded devices now, where they used to be just analog and you would have to provide your own analog to digital converter. The other great thing about I2C is it supports up to 128 different devices on the same bus. So with just 2 pins, we can support a ton of different sensors all at the same time, and you just have to plug them in parallel. They daisy chain on the bus. So that's about as easy as it gets. There are other devices that don't speak I2C, and for analog and digital simple stuff, we're going to talk about how we do that, and then the more complicated embedded buses like SPI and I2S and UART. That's in our future plans. We know that people need it, but we know that I2C can do 80% of what people need right now.
Yeah. Okay. Cool. All right. So we got this the dev board, which gives you I2C natively and kind of gets people started in a nice, easy way. So let's press on here and talk about what's next, which is the analog extension board. So talk about what it is, why people care about analog, why we're using it, and then kind of what sort of things it makes possible.
Yeah. So analog board, we find this really useful. So a lot of sensors out there, especially legacy sensors, are just going to give a voltage as an output to say what they're sensing. And these are things like photocells, a pressure transducer, simple, a rotational resistor, a potentiometer, or a linear potentiometer that's like a slider. You see those all over the place. They can be very easy to instrument some existing machine or process with. And you also find all these older sensors like infrared proximity sensors or ultrasonic proximity sensors that give an analog output just as like that way they don't have to have a digital bus on them. So there's a ton of them out there. How do you plug them into I2C? Well, this simple board basically takes the sensor bus and it brings it to just some screw terminals. So you can strip a little bit of wire and screw it in there with your flathead screwdriver. You don't have to have a soldering iron. We found that we want to make sure you never have to own a soldering iron if you're using Helium.
But you can if you want.
You can if you want. But we really want to help the people who never want to use a soldering iron. And so you can screw terminal into the voltage pins there. So 2 of those 3 pins are for voltage. You just put the ground and the high side in. And anything from 0 to 24 volts, you can measure, and we get you about a 4 millivolt resolution. So it's a 12-bit ADC in there. We can also measure a current. So there's some sensors out there that give a current, and this is it's really popular in factory automation because of these old standards like the 4 to 20 milliamp sensors, where there's various, from the electrical engineering, we get into a long story. There's a lot of advantages to having a current output. So we wanted to be able to enable those sensors as well. So we can, if you put it on the other two terminals or pair of terminals there, we can measure up to 0.5 amp. Which we find is flexible for most things, and you could even do some fun things like if you wanted to have a little electric motor where you're measuring load, you could measure that with our analog board.
Okay. So we've got the screw terminals. What are those jumpers for?
Yeah, so there's a bunch of jumpers. So one set of jumpers you're going to see on every extension board we make is the I2C address jumpers. And this is, remember I was saying the I2C bus, you can support up to 128 different devices. Yes. That's because there's 128 addresses on the bus that a device can live at. And because, a manufacturer of, you might want to hook up multiple of these same devices to the same bus, we need a way to switch them to a different address from their default. So the jumpers are there so you can select up to 4 addresses total for this device. Okay. So you can set it to address 0, 1, 2, or 3, and there's like a translation table to what actual address that maps to.
And we'll have
the idea is that way, because you can daisy chain these. If you take your breadboard and your jumper wires like this, you can hook up 4 of these to our dev board at one time. And it's just like if you had the same software-wise as if you had just one of them hooked up. It's you can just point the software at the second one you have plugged in as well and say, give me the current on our second analog extension board. Nice. So it makes that as easy as possible. You just push the jumper in the right place. Yeah. The other jumpers we have on there, there's one that it selects the different modes for this analog board. So, with nothing on the mode jumper, it's by default, like it just acts as a voltage and current sensor. Mm-hmm. We have one jumper position that's called the 4 to 20 mode, and that's for these 4 to 20 current loop sensors. These bottom screw terminals, the set of 2 screw terminals we didn't talk about yet, that's for adding a power supply to a current loop. So what we find is in a lot of factory settings, people want to install a new 4 to 20 sensor, and you need to power that somehow, and you need to power the Helium board somehow. Because it takes more power than you can get out of a battery for a long period of time. So that's what that's for. And the third jumper mode there is to use an external thermistor sensor. So we find a lot of people who need to measure temperature. A thermistor is, for a lot of situations, just the simplest way to get that done. So we support just plugging a 50K NTC, which means a negative temperature coefficient thermistor. A thermistor is just a 2-terminal device that's a resistor, but the resistance changes in a known way as temperature goes up and down. So right. You can plug that in. It does the right thing on the circuit to make it read basically the temperature out of there. You have to do a little bit of math, but we'll have software to make that easy.
Yeah, and if you go to, I was going to say, if you go to the Helium YouTube channel, which hopefully you're on currently, we've got a video of the analog board, and we demonstrate plugging in that thermistor that Pat just mentioned. We'll also have a sensor tutorial up on dev.helium.com probably within about 2 weeks, hopefully sooner, that shows how to plug that in and also what script does the controlling of that. So, yeah. Okay, so let's move on a bit here. So we've got the digital extension board, and I'm going to switch the slides over really quickly here. So we talked about the dev board, which is I2C natively. We talked about analog. Let's talk about the digital extension board here. So walk us through this, and don't forget to highlight all the very cool stuff, because there is some excellent stuff on this board.
Right. So the other thing is, so the digital board is, we only expose I2C, which is you have to have a sensor that talks this protocol, right? And so to take care of the analog side, we have one extension board. We find a lot of people have sensors that are really just simple digital switches. The switch is either opened or closed. And that's what this board is for. It's, I'll hold it up there. The idea is that you plug the sensor bus in here, and then you have 2 rows of 8 inputs each, 8 inputs or outputs each, plus power and ground on those. And in software, you can configure any of those pins to be either an input pin or an output pin. In fact, if you need to change from an input to an output quickly, you can do that too. It's totally flexible, programmable. The voltage rails are there, and there's some fancy features of this board where you can, if you need to talk to like a 1.8 volt digital device, you could set the voltage rail to be a lower voltage than the 3.3 it typically runs at. Most people won't need to do that. And the other cool thing is for the last 3 pins on the second rail, so that's IO 13, 14, and 15. We also have those hooked up to a programmable red, green, blue LED. So hopefully you can see that there by my finger. The idea there is we've seen a lot of people want to use some kind of feedback in their sensors, whether that's when they're configuring a sensor on a door that they want to be able to see it go red when the door's open, green when the door's shut, or maybe set off an alert when a temperature gets above a certain threshold or whatever. So that's totally programmable from your script. You just tell it what color to go. You can also program it to do cool things like fade in and out and blink in certain patterns. So that is connected to those 3 pins. You can still use those 3 pins for anything else you want. You just have to know the slight limitation that they have an LED in parallel with them.
Gotcha. Okay. I think I had one more question about this. So I don't know if you mentioned it, but it's got the same 10-pin sensor bus on it that all the other boards have?
Right. Yeah. So it's got the same I2C address jumpers as on the other board. They're just down in the other corner here, just because that's where they fit. The other jumpers on this, so one cool capability we have on the sensor bus, it's 3 of the pins on that bus are for sending an interrupt to the processor. And so what we found is that for power consumption reasons, we need to put the processor and the whole board and the radios and all that asleep as much as possible. And that's how we can get you multi-year battery life on just 2 AA's. But the thing is, you might want to wake up when some event happens in the external world. And what you can do with this digital board is you can program it to say, oh, when IO pin 4 rises, which corresponds to somebody pushed a button or somebody opened a door, I want you to wake the processor up and tell it. And so we allow you to select which interrupt line there, and that's just so that you can have like 2 of these connected.
And this is all done with a couple of easy lines of Helium script, yeah?
Yeah, exactly. So the Helium script, you can say, go to sleep until an interrupt happens, and it'll just wake up and say, hey, this is the interrupt that occurred. So we make that as simple as possible. It's it's one of those things that's hard to do in C and in embedded systems, and we went through the effort to make it really easy to just get a Lua procedure call that returns the right thing.
Nice. Okay, so let's move on to the last piece of hardware here. So we're going to talk about the 420 milliamp, which is my personal favorite. So this is the 420 milliamp smart sensor adapter, and just for some reference here, Pat, we got maybe 8 or 9 minutes left all in. Okay. So we built the 420 milliamp smart sensor adapter. It's actually built on the analog board, which Pat's going to highlight. And we did it because we got into a lot of situations where people were working on factory floors and in and around machines where there were existing sensors that actually output 4 to 20 milliamp already, and they just didn't have any way to kind of get them connected and get that onto the internet. So this is a pretty powerful little piece of hardware. So why don't you talk a bit about the 4 to 20, Pat? Yeah.
So I think the first thing is, before I started Helium, I didn't know anything about 4 to 20 sensors. So maybe some of you don't either. This basically, so here's one I'm holding up. The idea of a 4 to 20 sensor is that it just has a single pair of wires that is a current loop. So you apply some voltage across this positive and negative terminal, and the sensor permits an amount of current to flow. And what that means is because if you build a loop of wire, the current is always the same place at all points in the loop. then you can measure the current from multiple different places. So that's really useful for legacy equipment where it's like, oh, well, this 4 to 20 sensor is already hooked up to, old crusty SCADA system that I dare not touch. Well, you can tap into that wire and hook our smart sensor adapter up to it, and you're reading the same value. So that's like one nice thing about this old analog bus. It's called 4 to 20 milliamps because the smallest current you ever have flow is 4 milliamps, and the largest is 20. That's just nice small values that you can always get over a thin gauge of wire. So this particular sensor I was holding up, I have the wires bundled up, but this is a string potentiometer. And what this basically means is there's a string that you can extend. I think this is going to go 15 centimeters. You can buy these in all different shapes and sizes and lengths. But this is for like, oh, I want to measure how far along this robot claw is moving or whatever you have in your factory. And this basically just converts it to a rotational motion, and that will then, how far the string is pulled out gets eventually just converted to, so right now it would have 4 milliamps, now it'd be like 10, 12, all the way to 20 when I pull it out to the maximum distance. So that's a cool little sensor. And the idea is, if you were installing a new one of these, you would plug it right into one side of the smart sensor adapter. And because it's a new one, you don't have some existing infrastructure where it's already powered. So you would just plug in a power supply to those other ports on the two-side port there on the smart sensor adapter. And then that's a complete solution. Alternatively, if you already have a powered 4 to 20 loop in your infrastructure, you just plug in the loop to this smart sensor adapter, and it has a battery inside that takes care of all of its wireless functionality. So you don't have to be worried about running more power to this device. And it'll run for like 2 years on that little battery in there because it's only just powering the radio periodically. Just to give you an idea of the array of these sensors available, we had a customer asking about how do I measure noise level, which is one of those things that's important for OSHA. It might be important for noise regulations that are local to you. So this sensor I just managed to buy from emssensors.com, which seemed like a small outfit. And it's got a microphone, and it takes care of all of the circuitry to convert the average sound level to decibels, and then to convert the decibels. So it's like when it's 65 decibels, it outputs 4 milliamps. When it's 95 decibels, it outputs 20. So you can buy all these kinds of sensors because it's a standard, and they're available from a wide variety of sources, and you might already have some depending on what your application area is.
Yeah, and for those people interested on the specifics around the OSHA requirements, most factories will not be happy when the decibel level gets over about 90, which is a use case we've run across a few times. So cool.
Yeah. Okay. The other little thing I'll show you is this is for the more advanced users who might want to solder, might have some ideas about what they want to do. So we put the solder pads on the bottom of this board. You see those gold pads showing up? That is the same footprint, same pinout as our sensor bus. It's just meant to put a female connector on, and you if you wanted to solder that on, then you can get it so these boards sandwich like this, and so you just plug it directly into the sensor bus, and the holes line up and everything on the corner. And that is our smart sensor adapter. It's this plus another small board that takes care of our battery, and we just put it in a case. So if you don't want to do all that, we'll sell you a nice complete device.
Yeah, although we certainly encourage soldering. That's
yeah, we're really happy to see you hack and build new things out of this. That's our goal.
Yeah. Okay. So let me see if I can share my screen without killing this broadcast here. There we are. Okay. So anything else you want to say? We've run about 28, 29 minutes here. Anything else on your mind about the hardware? Any big features we didn't touch on?
I'm just going through my notes. I think I covered most everything I wanted to. The other cool thing is, so we were saying like, okay, so we including this kind of cable. We want people to breadboard. Going to sparkfun.com or adafruit.com, which are two really great US-based vendors, and there's various other vendors around the world. You can get all kinds of little sensors. This one is just is a particular ADC. And so they come on these little, blue or red breakout boards, depending on which vendor you brought it to. And they have just the power, the ground, the serial I2C data and clock pins labeled. And they come with that. They come with a little set of pins that you might solder onto there. Or so you can stick this into a breadboard. You can plug it directly into this octopus cable, as we call it. So you can plug it directly in that way. So the idea is, there's hundreds of these out there, maybe thousands, and we want you to be compatible with all of them. So one of the things we're going to do over the next coming months is release reference scripts that run a lot of these. You'll often go to these Adafruit and SparkFun, and they'll have an Arduino script that runs for them. And
right.
Perhaps everybody knows Arduino, but it's programming in C. It's got a lot of these pitfalls. So we can't run Arduino scripts because we picked a different language that has a lot of safety and development convenience advantages. But we will release reference scripts for a ton of these. And we'll probably end up doing a tutorial that says, oh, if you see an Arduino script for it, here's how you would translate it to a Helium script. They'll kind of describe it to you to do that. And you also might have to just read the data sheet for the part a little. It's a skill. It's not always the easiest thing to do, but
well, I mean, we're trying to make the process as easy as we can. We're also happy to walk you through some script writing, or maybe script translation from C over to Lua, or Helium script specifically.
Yeah, exactly. We've got a ton of people in the Helium chat channel who are experts at this stuff. So if you come up with a sensor and say, I don't know how to hook it up to this hardware, that's fine. We'll give you a hand. We're more than happy to.
Yeah, I think we've got almost 10 tutorials in the pipeline. They're not all going to be released at the same time, but we've got a handful of sensors that we're going to build scripts for. And if you have a specific sensor that you want to use with your dev kit, or one that you're about to buy, drop into chat.helium.com and mention something, and we'll see if we can get a script written up for that one. Yeah. Okay, so that's going to take us just over 30 minutes. A few announcements before we get going. I mentioned before that we just launched dev.helium.com, so dev.helium.com. This is our new home for everything that is developer. It used to be docs.helium.com, and now it's docs plus a whole bunch of great stuff. So guides, tutorials, we've got some videos on there. We've got a couple logos from companies and developers like WeWork and Kinetic Vision and Kava Grill, who are building on top of Helium, and a whole bunch of other good stuff. I also wanted to mention that we're going to do a full day IoT training in Chicago on March 9th. So we actually haven't publicized that at all yet, but we just solidified it today. So I'll be sending this around to the mailing list, and I will probably tweet it, and I'll put it in the notes for the show. So I think that's about it for the moment. Pat, anything else on your mind?
No, I think we're good. Thanks for having me on.
Yeah, my pleasure. Thanks for helping us out here. And everybody should go to store.helium.com and buy their dev kits. All right, Pat, I'll catch you later.
So long. Bye.
Bye.